Welcome back to the channel, guys. Hope you're doing extremely well, and this is your very own mask code this side. Welcome to yet another lecture of binary tree. So in this video we are going to discuss about the maximum depth of the binary tree, which is also known as height of a binary tree. So as the name of the question suggests, okay, so what is the height of this binary tree? Height of this binary tree. So I can see that this height is 1, 2, 3. Maximum height is 3. So answer to this problem, that is problem A, is 3. Similarly, answer to problem B is 1, 2, 3, 4. Answer to problem C is 1, 2, 3, 4. Right? So my answers are 3, 4, 4 respectively, and you can see the answers are pretty well like height of the binary, right? Height of the binary. I can say it as depth also. How can I say depth? So if I stand at 1 at this node and I see the depth and I see the depth, that is, it is going one level deep, second level deep, and I'm standing at first level, so it is second level, third level, so it is 3 levels in total, so I am returning 3, right? That means the maximum depth and that means the height. Both are same. The question will give you the node, that is this root node, and will try to ask you that what is the height of the given binary tree. How will you solve it? How will you solve it? Right. Okay, so my first approach is, as I know, I've already studied about the traversals. I have already studied about the traversals. And as you are my viewers, I want to tell you about 90% of the problems, 90% of the problems related to binary tree are solved using traversals, right? So it is most probable that your OA question is actually asking you to traverse, but in certain fashion. Obviously, certain question demands certain things, so we have to modulate our traversals accordingly, right? We have to use pre-order somewhere, we have to use in order somewhere, you have to use post order somewhere, etc., etc., right? Now, as I was describing the problem, suppose I take out this example, that is the first tree: 1, 2, 3, 4, 5, 6, 7. As I was explaining the output scheme, you can see that I marked something like this: first level, second level, third level. First level, second level, third level. So actually I was saying how many levels are there? How many levels are there? My real question was how many levels are there? How many levels are there? Right? This was my question. So can you tell me, from what we have studied up till now in the playlist, can you tell me how can you determine the number of levels? Can you determine the number of levels? I think yes, you should be able to. How? We have already studied about the traversal known as level order traversal. We have already studied about the level order traversal. So if I take the level order traversal of this binary tree, it would look something like this: 1. In the second list, it will be 2, 3. In the third list, it will be 4, 5, 6, 7. Right? And if I say that traversal's name array is ARR, then can I say that my answer will be ARR dot size? My answer will be ARR dot size. So you can see 1, 2, 3. Size of the ARR is 3, and my answer will also be 3. You can test it for another values also. So for this case, my level or traversal will do something like this. Level or traversal will something like 1 with 2, 5, with 3, 6, 7, with 4. So you can see 1, 2, 3, 4. Answer is 4. Similarly here 1, then 2, 5, then 6, then 7. So 1, 2, 3, 4. Answer is 4. So I hope that is clear to you. So the first and the easiest approach is that we have already learned, that is, do the level or traversal and return the size. But what is the time complexity of the level or traversal? So there are n nodes. So it is taking a time complexity of O of n, as well as it is taking a space complexity of O of n, because I'm storing the nodes as well, right? I am using the queue also. If you remember, for level or traversal we used a queue, so O of n is the space for queue also, and O of n is the space for array also, right? Can I reduce that? Can I reduce this array space? Can I reduce this array space? How? I can reduce this array space. The scheme is that I don't want the traversal. I do not want the traversal. I just need the number of levels. I just need the number of levels. So what can I do? I just need a number of levels. So what can I do? How can I proceed? So I can say, in the case of level or traversal, when I was adding the answer to the, like adding the level to the answer array, right? This was my certain scheme that I will create a new level and then I will add that to the traversal, existing traversal. Instead of that, just say level plus plus. That is your answer plus plus, and you will just get the size of the array without without adding it, right? Without adding it. So in that case, your time complexity is still O of n, but the space complexity is reduced to, it was O of 2n here because of the queue, but it is now, oh sorry, It is now O of n, right? Okay, so it is slightly optimal, but not the all optimal right now. But it is not fully optimal right now. How can I make it fully optimal? So let me take you to a new concept. Let me take you to a new scheme. So suppose my binary tree is looking something like this: 1 connected to 2, connected to 3, connected to 4. Suppose right is empty, connected to 5, connected to 6, connected to 7. Right? This is my binary tree. This is my root, obviously. This is my root. I have been given this as a reference and I want to denote the what is the height. I want to find what is the height. I want to find what is the height. Right. Okay. How can I do it? How can I do it? Can I say that if I know the height of this one and the height of this one, if I know the height of this node and if I know the height of this node, can I tell the height of this node? That is, if I am saying that if, let me change the ink, if I know the height of this node and if I know the height of this node, I can easily tell the height of this node. How? So suppose height of two node is L, height of R, right, three node is R, right? Height of two node is L, height of three node is R. What is height of two node? You can see in the observation the height of two node is 1, 2. It is equals to 2. Height of three node, that is this node, is R, which is equals to 1, 2, 3. Right? So which one will I choose? Which one will I choose? So we know that L equals to 2, R equals to 3. We will choose the maximum of them. We will choose the maximum. We want the maximum height only, right? So you can see that up till this level, both trees have same height, but this node is actually giving the R a edge, a edge. Okay, so you can see in the height also 1, 2, 3, 4. The fourth node is this one, right? The fourth node is this one. So I will choose a maximum among them. So maximum of LR. Now I want the height of this node. I want the height of this node. So it is actually equals to maximum of 2 comma 3 plus 1. Maximum of 2 comma 3 plus 1. You can see that my height is actually 4 and 3 plus 1 is actually giving me 4. So what is the height of a root? Height of a node is equals to maximum among height of left subtree, height of left subtree plus height of right subtree plus 1, right? So what is the height of a node? It is height of the left subtree plus height of the right subtree plus 1. That is, I am saying for this one I need the values of this 2 and this 3, but for this 2 I want the values of 4, and if there was a right one also, so I will have to choose right one. Now the concept is, if there is not a node, you can see the right one is empty, so what will I return? So if there is no node, that means the height is 0, so I will be returning 0. This will be 0. Height will be 0 here, height will be 1 here, so I will be choosing 1 plus 0. 1 comma 0 will give me maximum as 1, and 1 plus 1 give me 2. So you can see I am getting 2 here. Similarly, 5 is returning 1, 6 is returning 6 is check first. So 6 will check, it will return 1, but is this node is 0. So 1 plus 0, sorry, 1 comma 0, what will be the maximum? 1 will be the maximum. 1 plus 1 gives me 2. So 6 node has a height 2. Again the maximum is 2. So 2 plus 1 gives me 3. 2 comma 3, maximum is 3. So 2 plus 1 gives me 4. So my answer will be 4. What is the scheme? What is the scheme? We start from the leaf nodes. We start from the leaf nodes. Height is 1. Height is 0. 1 comma 0 gives me 1. 1 plus 1 gives me 2. Height is 0. Height is 1. Maximum is 1. 1 plus 1 gives me 2. We get 2. 1 comma 2, we get 3. 3 comma 2, we get 4. Right? So this is a scheme. We are actually moving something like this. Etc. etc. Right? We are going from bottom to the top. We are going from bottom to the top. We are going from, this is known as bottom to the top. We are going from bottom to top. Right? Now, how will I write it? How will I write the code? The main thing is to write the code. Right? The main thing is write the code. How can you do it? So you can see something. So if I highlight these words, height, 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 the problem gives me that I want to find the height of a node. That means it calls the function f of root, right? It calls the function f of root. Can I say that for the left subtree I can call f of root left, f of root left, and similarly for the right subtree I can call f of root right, f of root right. If f returns me height of this root node, then f of root of left will return me height of left subtree, and f of root of right will return me height of right subtree. I will choose the maximum, I will add 1, and I will return the answer. That is the problem to me. That is the main thing to me. So what is my pseudocode going to look like? So it will be simple. Suppose my function's name is f and it is getting a root. The base case is that if my root is equals to null, if my root is null, that is this circled case, that is this green circle. So I'm returning 0 in this case, because if it is null, then it is contributing nothing. It is contributing nothing. So in that case, return 0. Otherwise, what will you do? You will calculate the L height, that is the left subtree height, which is equals to f of root left. And similarly, R, that is the height of the right subtree, will be f of root right. Right? Okay. Now, what is the height of this root? It is equals to 1 plus maximum of these. So, return. What will you return? 1 plus maximum of L comma R. 1 plus maximum of L comma R. 1 plus maximum of L comma R. Suppose, for example, let us try run it again. Suppose my tree is 1 connected to 2, connected to 3, connected to 4, connected to 5, connected to 6, connected to 7. Right? So I will be first calling this one. I will be calling this one, which will call this one and this 2. 2 will be calling 4 and this node. Right? So what, and 3 will be calling this node and this node. 5 will be calling this node, that is 6, and 7 will be this. 6 will be now calling this and this. 7 will be calling this and this. Okay. So what is the recursion tree going to look like? The recursion tree is exactly same as the binary tree. This 4 will be returning. This 4 will be calling these two nodes which are actually empty. So 0, 0. Maximum is 0. So I will be getting value 1 here. I will be returning 1 here. And this node is actually returning 0 here. 1 plus 0. Maximum is 1. So I will be returning 2. I will be returning 2 here. Coming to 3. 3 will go up till 7. 0 here. 0 here, so I will be returning 0 plus 1, 1 here, 0 here, 0 here, 0 plus 0, 1 here, 1 here, 1 here, that I will be adding 1, 2, 0 here, maximum is 2, so I will 2 plus 1, 3, I will be returning 3 here, 2 is getting returned from here, 3 is getting returned from here, maximum is 3, so 3 plus 1 is returning 4, so my root node is actually returning 4, you can see the height also, so 1, 2, 3, 4, 4 is my height, you can see answer is also 4. This is the exact function you need to write down into the code. So I hope that is clear to you and we are free to move to the coding section of the area. Alright guys, so here is the coding section, but before starting with the code, I would like to request you to please subscribe to my channel because it really motivates me. Please like the video, and if you are learning anything from the playlist, please engage with me in the comment section. My social media handles are also available in the comment section, so please feel free to watch, to go through my pages, etc. and interact with me, right? Okay, so let us start writing it. So if my root equals to null, that is my base case, right? That is my base case. What will I do? I will say return 0. Otherwise, height of length, the height of left subtree is equals to int L equals to max depth of root left, Similarly, int R equals to max depth of root right. It will be int, sorry, for example, a timing mistake. It will be int root right. Right? Now what will I return? I will return 1 plus maximum among L comma R. That will be my code. Let us try to run it. It should run fine, I guess. Should not give any error. Okay, it is running fine for the sample test cases. Let us try it for the submit as well. Alright, it is running fine. So thank you for watching and hope you liked it. Please do support me by subscribing and interacting with me. Thank you. Have a nice day.